Hi everyone. Today we're going to be looking at how to deal with a transformed square root function. So in your notebook, please put today's subtitle, Transformed Square Root Function. The transformed square root function has the following format. Y equals a multiplied by the square root of b times x minus h, and then plus k is outside the square root symbol. And every variable involved has some impact on the shape of the graph. As with many functions, predictably, the h and k reveal the x and y coordinates of the vertex. And, perhaps most interestingly, the value of a and b interact together to impact the direction of the graph. The next thing to look at is how the direction of the graph is affected by the interaction between A and B. There are four possible scenarios. The first scenario is what happens if A was positive and B was positive. Well, in this scenario, the graph starts from the vertex and then it flies up and to the right of the vertex. The second scenario that can happen is what if A was positive but this time B was negative? Well, again, the graph will start at the vertex, but this time it will fly up and to the left of the vertex. The third scenario that can happen is what if this time A was negative but B was positive? Well, in this scenario, again the graph starts from the vertex, but this time it flies down and to the right from the vertex. And finally, the fourth scenario that can happen is what if both A and B were negative? In this scenario, again, the graph starts from the vertex, but this time the graph flies down and to the left of the vertex. The next item that we'd like to know about the transformed square root function is the zero. And notice that there's no plural this time. A transformed square root function will always have 1 0, if any. And as usual, to calculate the zero of the square root function, all we have to do is set y equal to 0 and solve for x. In this case, we'll be solving a square root equation. And finally, the last bit of information that we'd like to have is, of course, the initial value. And for that, as with any other function, we set x equal to 0 and solve for y. One little note to keep in mind is that due to the inaccurate nature of drawing this type of graph, most teachers would like you to at least have 3 or 4 points to draw a decent graph. So this will probably involve plugging in some random x values to get you a couple more coordinates. Alright, I think it's time to try drawing one function. So, for your example please, suppose I ask you to draw the following function. Draw y equals, how about 2 multiplied by the square root of, how about 0.5 multiplied by x minus 3, and then the k value is minus 1. Now first things first, let's write down all the variables in front of us so that we can see them easily. The value of a is equal to 2, the value of b is equal to 0.5, value of h is equal to 3, watch out for the danger involving the x subtract h, and the k value is negative 1. Okay, first things first, let's clearly identify the vertex. The vertex is obviously located at h and k, and in our example, it will be located at 3 and minus 1. Next, let's identify the direction that this graph is going to have. So direction is based on the sign of A and B together. In our example, A is positive and B is positive. Therefore, this graph will start at the vertex and then fly up and to the right. Next, let's calculate the zero of this function if there are any. So, to calculate the zero, all we have to do is set y equal to 0 and solve for x. So that gives us 2 multiplied by 0.5 times x minus 3 minus 1 equals to 0. First, let's isolate the square root expression itself. So this will give us 2 multiplied by 0.5 times x minus 3 equal to 1. Then we continue, 0.5 times x minus 3, all square root, is equal to 1 over 2. And now that the expression is isolated, let's square both sides. So this will give us 0.5 times x minus 3 is equal to 1 over 4. And then we have x minus 3 is equal to, let's see, 1 over 4 divided by half, I believe, gives you 0.5. And then finally, x will equal to 3.5. So there is a 0 in this example. Sometimes there might not be. And finally, let's calculate the initial value of this function. And strangely enough, in this particular function, sometimes you may end up with no initial value. So let's see what happens in this case. So y is equal to 2 multiplied by 0.5 times 0 minus 3, and then minus 1. When we simplify, we get y is equal to 2 times the square root of negative 1.5 minus 1. Aha! Here's something interesting. We have the square root of a negative number, which is not allowed. So our operation cannot be finished, and that means that there is no initial value. Interesting. Well, this presents a slight problem for our graph because so far, if you count it up, we only have 2 points. And to draw a nice, decent graph, we'd like to have at least 3 or 4. So we have no choice. Let's get a third point simply by plugging in any random x. So I'm going to do the following. I'm going to calculate the value of y at x is equal to 11. Now there's a reason why I picked 11, and I'll mention it in a few moments. Let's plug it in and see what happens. So y is equal to 2 multiplied by the square root of 0.5 times 11 minus 3 and then minus 1. Simplifying gives us y equals 2 times the square root of 4 and then minus 1. And here is why I chose to plug in x equals to 11. It's because when you simplify the expression in the square root symbol, I got a perfect square number. And I highly recommend that you do the same thing. Although, if you're not afraid of really, really messy numbers, feel free to pick absolutely any x that you want. And finally, further simplifying, this will give us a y value of 3. So we have our third point, located at 11 and 3. Finally, let's draw the graph. To accommodate our 3 points, you're going to need a grid that's about this size. So go ahead, pause the video, and prepare your grid. Alright, with your grid in front of you, let's put down our points. First, let's put down our vertex, located at 3 and minus 1. So vertex is about right there. Next, let's put in our 0. The 0 was located at the coordinate 3.5 and 0. So that'll put it about here. And finally, let's put down that third point we calculated, located at 11 and 3. So that will put it all the way out here. And then do your best to draw a nice, decent curve connecting all those 3 points. If you have trouble connecting the points properly, feel free to give yourself more points if you need to. And that's all there is, ladies and gentlemen, to how to draw the transformed version of the square root function.